Hello everyone, today we're going to be going over the August 2024 Algebra 2 Regents exam. In this video, we're going to be focusing on part 2, which is 8 short response questions, each worth 2 points. A link to this test can be found in the description of this video if you want to follow along at home, and a link to a video going over the next part of this test is also there if you want to continue going over this exam after this video. That being said, we're going to start off at number 25, which tells us that on the axes below, graph y equals 3.2 times 1.8 to the power of x. So whenever we have a problem that requires us to graph something or asks us to graph something, I'm always going to put it into my graphing calculator. So I'm going to go ahead and I'm going to copy this, press y equals, and then enter 3.2 times 1.8 to the power of x into my calculator. I'm going to press graph. And my job here is going to be to copy this curve or this shape onto this page using at least 3 points, okay? So the first point that you're going to need for this problem is going to be your y-intercept, so the point that's along this graph. The second point is going to be any point that's to the right of the y-intercept, and the third point is any point to the left of the y-intercept. So in order to figure out what my points are, I can hit second graph, and that'll give me a table with all the coordinates. So the first coordinate I want to do is my y-intercept, which is always when x is equal to 0. So I have 0, 3.2. That's my first point. So I'm going to go 1, 2, 3, and 3.2 is somewhere at the bottom of this. So let's say 3.2 is there. Okay. Now I want to choose a point to my right of my y-intercept. So any positive x value. In this case, I'm going to do 1, 5.76. So here I can go 1, and then 1, 2, 3, 4, 5. Here's 5. 5.76 is going to be just below 6, so somewhere here. And finally, I'm going to plot a point to the left of my y-intercept. And in this case, let's do negative 3, 0.54. So negative 3 is 1, 2, 3, and 0.54 should be the middle. So now that I have my 3 points, I just need to connect it with a line that looks like my graph, right? So it's going to be flat near the x-axis, and it's going to be almost vertical or approaching a vertical line as it reaches a positive x value. So that's going to look something like this. So make sure your line passes through all of your points. Make sure you draw an arrow at both ends of your line, and make sure that your line isn't jagged. Don't connect the points with the line. Don't go 1, 2, 3, 4. Don't have sharp edges or sharp angles. Try and make your line smooth as possible and upwards, like the graph or the shape in our graph over here. Okay, moving on to number 26, it asks us whether x plus 6 is a factor of this polynomial. Now, whenever you want to figure out if something is a factor of a polynomial, you're going to see if it evenly divides into that polynomial or if there's no remainder. What I mean by this is if you have any number, this rule applies to any number. If you have like the number 6, for example, if you divide 6 by any of its factors, it's going to evenly divide. So for example, 6 divided by 2, 6 divided by 3, 6 divided by 6, and 6 divided by 1 are all going to yield numbers with no remainder, right? 6 divided by 2 is 3, 6 divided by 3 is 2, 6 divided by 6 is 1, and 6 divided by 1 is 6, right? There's no remainders when you divide it by its factors. So the same should be true with 7x cubed, plus 27x squared plus 9x minus 27. If I divide this by one of its factors, I should not be left with a remainder. So I'm going to divide it by x plus 3. Now, whenever you're dividing by a polynomial by one of its alleged factors, it's going to be a simple process. It's just like regular long division. So let's say you were dividing 2 by, like 256. You would go the same way. Well, how many times does 2 go into 2? 1 time. 2 times 1 is 2 minus. Then you drop down to 5. How many times does 2 go into 5? 2 times. 2 times 2 is 4. So you're following that exact same process, just with variables. So in this case, how many times does x go into 7x cubed? Well, it's going to go in 7x squared times. If this ever confuses you, how do I know that 7x times 7x squared is equal to 7x to the power of 3? What you can do is you can write down this number, 7x cubed, and divide it by this x that you're dividing it by, right? So you're trying to see what number do you have to multiply x by to get 7x cubed? Well, you can just say that, well, x times this mystery number is equal to 7x cubed. Divide both sides by x, okay? And if this confuses you, you can write this out fully. You can write 7x cubed as 7 times x times x times x. if you divide this by x, well, one of the x's is going to cancel out, and you're going to be left with 7 times x, or 7x squared. Okay, so you can always follow that if you get lost or confused. Now that you have that, you're going to multiply, just like regular long division, you're going to multiply x by 7x squared. Obviously, you're going to get 7x cubed, and then you're going to multiply 7x squared by 3, right? So plus 3 times 7x squared, which is going to be 21x squared, and then just regularly divide it. So these two are going to cancel out. 27x squared minus 21x squared is going to be 6x squared. You're going to carry down the 9x. Okay, now how many times does x go into 6x squared? Well, it's going to go in 6x times, okay? 6x is equal to 6 times x divided by x is going to be 6x. That's what it means. So x times 6x is 6x squared. 3 times 6x is going to be positive 18x. Subtract these. 9x minus 18x is negative 9x. Carry down the minus 27. Okay, how many times does x go into negative 9x? Well, negative 9 times. X times negative 9 is negative 9x. And 3 times negative 9 is negative 27. If I subtract these cancel out, and I have no remainder. So remember our rule. If we divide something and it has no remainder, aka it evenly divides into it, it is a factor. So then I just have to draw that conclusion by saying that yes, x plus 3 is a factor of 7x cubed plus 27x squared plus 9x minus 27 because it evenly divides. Or you can go ahead and say that yes, because, it's a terrible way of writing because, but you can say yes because 7x cubed plus 27x squared plus 9x minus 27 divided by x plus 3 has no remainder. So as long as you say yes and you reference the fact that this division gives you no remainder, that's enough justification to say that it's a factor. Okay? Number 27 says, over the set of integers, factor the expression 2x to the power of 4 minus 10x cubed plus 3x squared minus 15x completely. So whenever the Regents gives you a factoring problem and they make it 4 terms long, what I mean by 4 terms is 1, 2, 3, 4. There's 4 parts to this. What you want to do is split it through the middle. You always want to split it through the middle and factor out those subsequent parts. So if I split this down the middle, I now have 2 parts. I have the part on the left and the part on the right. And I promise you, if you do it this way, they're always going to factor into the same number, okay? Or into the same expression in a set of parentheses. So how can I factor out 2x to the power of 4 minus 10x to the power of 3? Well, I can take out 2x to the power of 3, and I'm left with x minus 5, okay? Now, I'm going to go ahead and do the same thing for my right side. What can I take out of 3x squared minus 15x? Well, I can take out 3x, and if I take out 3x, I'm left with x minus 5. And this is what I was talking about. If you split it up into a left and a right side, they will always factor in, just on the Regents, they will always factor in into 2 of the same parentheses. So now, treat it like you were foiling anything. Like you were factoring something using FOIL. Just combine these 2 parentheses into 1 x minus 5, and combine these coefficients into their own parentheses, 2x cubed plus 3x, okay? Now, is this your answer? No, because you can take out an extra x from this parentheses. Don't fall for the trap. So if you factor out x, you get 2x squared plus 3 times x minus 5. That's the answer in this case. If you were confused on how I knew to take out 2x cubed, again, you can always break these down into their components. So for example, and this might be useful for problems like these where it's not obvious what goes into both of these numbers, what you can take out, just break them down. So 2x to the power of 4 is the same thing as saying 2 times x times x times x times x, right? X to the power of 4 is x multiplied by itself 3 times, okay? 10x cubed is the same thing as saying 10 times x times x times x. So 3 times, right? Because it's x cubed. Now, when you look at this, the way that you determine what you can take out of both of these, what number goes in this position right here, is what matches up, so what aligns. Well, in this case, they have an 1x in common, 2x's in common, and 3x's in common, right? So they have x times x times x in common. X times x times x is x cubed, right? So you can take out x cubed. Now, what else do they have in common? Well, what else they have in common is this 2. Remember that 10 divided by 2 is equal to 5, and 2 divided by 2 is equal to 1. So you can take out a 2 from both of these numbers. They share a 2 in common. So they share an x cubed in common, we just saw, and they share a 2 in common. So we just add that or multiply that to the x cubed that we just took out, and we're left with 2x cubed, okay? So again, you can always break apart things into their basic parts and see what they have in common whenever you want to take something out, all right? Moving on to number 28, it says that the monthly unemployment rate of towns in the United States is approximately normally distributed with a mean rate of 5.2%. So the mean is equal to 5.2% and a standard deviation of 1.6%. And they're asking us to determine the percentage of towns to the nearest integer that have a monthly unemployment rate greater than 6%. So we want something that's bigger than 6%. Whenever they give you the mean and the standard deviation, and you want to see the percentage of data that's greater than a certain value or less than a certain value, you're going to be using the normal CDF function on your calculator. Okay, what the normal CDF function on your calculator does, I'll show you right now, is if you go into second and then vars, press 2 or scroll down and press enter, they both do the same thing, it gives you a percentage based on a lower value, an upper value, a mean, and a standard deviation. Okay, so it pretty much takes this normal distribution curve and it calculates what percentage of data is going to be within the range that you gave it. So in this case, the range of my data is going to be the range that says that is greater than 6%. Okay, so something that's greater than 6% is going to give you a range of data, right? What's greater than 6%? Well, 7, 8, 9, 10, 11, 12, so on and so forth, right? So that range, stuff that's greater than 6%, is going to start at 6% and it's going to go on forever, right? So when they ask you for the lower or the lower value, they're asking you for the start of your range or the smallest possible value that can be in your range. So right here, what did I just say? Well, 6 has to be your lower value because it's how many towns have an unemployment rate greater than 6. So the smallest value that they can have is 6 because you're trying to see, well, what's bigger than 6? What percent of them are going to have a town that or an unemployment rate that's bigger than 6? Okay, so you're starting from 6 and you're looking onwards. So your lower is going to be 6. Now your upper is just going to be a big number. We can put it as 100, especially in this case because we're dealing with percents, we can just leave it as 100. So we're searching, this calculator function is going to search what percent of data is going to be between 6% and 100%. Okay, so how many towns are going to have an unemployment rate between 6% and 100%? AKA, we're looking at the unemployment rates that are greater than 6%. Okay, 100% is going to be the maximum, right? Because everyone can be unemployed. Whereas the smallest amount is going to be 6% are going to be unemployed. From there, all you need to do is just plug in the rest of the values. They gave you that the mean was 5.2% and they gave you that the standard deviation was 1.6%. So if you go ahead, hit paste, enter your data, press enter, it's going to give you 0.308, okay? Now they want you to round this to the nearest integer. So 0.308 turns into 30.8%. And this rounded to the nearest integer, to the nearest whole number, right, is going to be 31%. So the answer is 31%. Now, to show your work for this, all you need to do is just write down what you put in the calculator. So write down normal CDF, 6, 100, 5.2, 1.6. So it's the exact data that you plugged into your calculator. You're going to put that on your test booklet or your answer sheet, and that's what's going to give you full points for showing the work. Moving on to number 29, it says that the function d of t is equal to 2 cosine pi over 6t plus 5. And it's saying that this equation models the water depth in feet at a location at a bay t hours since the last high tide. It's asking you to determine the minimum water depth of the location in feet. So in this case, we can go about this problem in 2 ways. Our first way we can do it is by graphing it and looking at the minimum. So we can go into our graphing calculator, type in 2 cosine pi over 6 x, close the parentheses, plus 5, and then just get rid of my old graph because I didn't mean to put it here, right? And then we can go into mode, make sure that we're in radians, and then press graph, okay? And it's going to give you this wave function. And pretty much this wave is going to oscillate between or go in between these low points and these high points, okay? So you can go second trace and then calculate or find the minimum, right? So you're going to, when they ask you for a left bound, you're going to choose a point to the left of your minimum. The right bound, you're going to choose a point to the right of your minimum. And then when it asks you to guess, you're going to place your cursor on the point that you want to know. So here, I think that my minimum is somewhere around here, so I'm going to tell the calculator to look for it around here. So the minimum is going to be 3, right? The minimum is going to happen around -6 or every -6, and it's going to be 3. So my minimum is 3. Now, that's graphically we can do that. If we wanted to do this another way, we can look at the actual function. D of t is equal to 2 cosine pi over 6t plus 5. So this is going to be my amplitude, and this is going to be my midline. And pretty much the way that these sine or cosine functions or these trig functions work is that they're centered around a midline. The entire function occurs either above or below this line, this midline, right? And how much it goes up or down from the midline is determined by the amplitude. So a graph with an amplitude of 2 is going to change or switch between 2 units above the midline and 2 units below the midline, and then 2 units above the midline and 2 units below the midline. So it's all centered around the midline, and the amplitude is how much above or below it'll be. So if we know that the midline is 5, this point is 5, and the amplitude is 2, we're switching between a maximum value of 7, which is the midline plus the amplitude, and a maximum value of 7 and a minimum value of, well, if this is 5, 5 minus 2 is 3, right? Because then we go down by 2. Here we go up by 2. So in this case, we can justify our answer by referencing this, right? We can say that the minimum value for d of t, right? Yeah, the minimum value of d of t is 3, right? The minimum value is equal to the midline minus the amplitude. So in this case, the midline is 5 and the amplitude is 2, and that gives us 3. Otherwise, you could have graphed it. You could have made a set of axes and then graphed it out over a given set of values and then shown that the minimum value happens at 2. Either way works here. I just think that this is easier and it saves you time because you don't have to graph it. Number 30 says, a brewed cup of coffee contains 130 milligrams of caffeine. The half-life of caffeine in the bloodstream is 5.5 hours. Write a function c of t to represent the amount of caffeine in a bloodstream t hours after drinking 1 cup of coffee. So the way that a half-life equation works is the half-life tells you how long it takes for half of something to go away. Okay? So essentially it's saying that if you start off with 130 milligrams of caffeine, 50% of it will be gone, or 50% of it will remain. 50% is the same thing as 1/2. So 50% will be remaining after 5.5 hours pass, right? So we start off with 130 and we're left with 50 after 5.5 hours. Well, the only way that we can be left with 50 is if we have t over 5.5. And this is what's going to represent c of t. Whenever you have a half-life problem, you're going to put your initial first. So my initial is 130. Then you're always going to multiply it by 0.5. Okay? It's always just going to be a rule like that. Why? Because half-life, it's literally in the name, it's half, right? It's going to be the life that half of that substance lives, right? So half of that substance is going to be gone. Half is represented by 0.5. Okay, so this part should be easy. Now the exponent just tells you how often it happens. So in this case, that's going to be t hours over 5.5. Why? Because it takes 5.5 hours for half of the substance to disappear. So it's not going to be 5.5 times t, because 5.5 times t, if 1 hour passes, that means that my exponent is going to be 5.5. So 0.5 to the power of 5.5 is equal to this tiny number. That means that after 1 hour, 2% of the substance remains. That's not right. 50% of the substance is supposed to remain after 5.5 hours. But if we have t over 5.5, and if I plug in 5.5, I'm left with 5.5 over 5.5. This turns into 1. And 0.5 to the power of 1 is 0.5. So I'm now left with 130 times 0.5, or half, after t over 5.5, right? Or after 5.5 hours. So this is going to be your equation, okay? A cool trick for this would be you're going to divide if the half-life is longer than your units. So your half-life here is 5.5 hours, and your units is 1 hour. So this is the half-life, the HL, and your units is going to be t hours, okay? Or let's just say that it's 1 hour. So in this case, because the half-life is greater than your units, you're going to divide the units by the half-life, or the time of the half-life, okay? If the units are greater than the half-life, then you multiply the two together, okay? And the nice way that I like to check that out is just by plugging in the half-life and seeing if it makes sense, right? If it turns the exponent into 1. Number 31 says that Marcus is a long-distance walker. In one race, he walked 55 miles in t hours, and in another race, he walked 65 miles in t plus 3 hours, and his rates are shown in the equation below. Marcus walked an equivalent rate r for each race. So in both of these, he walked the same rate. So because they're both in terms of r, we can actually set these two equations equal to one another. So we can go 55 over t is equal to 65 over t plus 3. And the reason we're doing this is that so we can solve for t, right? It's asking us to determine the number of hours that each of the two races took. Okay, so you have 55 over t is equal to r, and 65 over t plus 3 is also equal to r. So they're equal to the same thing, which means I can equate them together. Now, in order to solve for t, I just need to cross multiply. So I multiply 55 by t plus 3. I'm left with 55 times t plus 3 is equal to 65 times t, or 65t. Now I need a factor or distribute this 55. So I'm left with 55t plus 55 times 3, which is equal to 165, plus 165 is equal to 65t. Now I subtract 55t from both sides, and I'm left with 165 is equal to 10t. In order for me to get t on its own, I divide both sides by 10, and I get that 16.5 is equal to t. Now, the problem is asking me determine the number of hours that each of the races took. Okay? So, one of the races took 16.5 hours. That's what t is equal to. But remember that another race, he walked 65 miles in t plus 3 hours. So, it's not just 16.5, or it's not just t, it's also going to be t plus 3. So, 16.5 plus 3. He walked at two different times, right? So now the other t is going to be 19.5. So the correct answer is 16.5 and 19.5 hours. And that's all you really needed to do, okay? The rule to remember here is that whenever you have these two rates, you can set them equal to one another, and that don't forget, don't just solve for one t, solve for both, okay? Number 32 says, solve the equation x squared plus 3x plus 11 is equal to 0 and express the answer in a plus bi form, okay? So whenever you see a plus bi form, think quadratic equation, right? Whenever you're asked to solve an equation, you're asking to solve for these zeros. And the way that we usually do that is by using the quadratic formula, okay? This a plus bi is a dead giveaway that we're going to be using the quadratic equation, which is negative b plus minus radical b squared minus 4ac over 2a, okay? So all we need to do is take this equation, x squared plus 3x plus 11, and plug in those values into this equation over here. So a is equal to 1. Why? Well, a is always going to be the coefficient in front of x squared. You may be saying, well, there's no coefficient there. There's no number in front of the x squared. There's actually an imaginary 1. 1 times x squared is equal to x squared. So there's always going to be an imaginary 1 there, okay? Now, the b is going to be the coefficient or the number in front of the x that's not squared. So my b is equal to 3, and my c is going to be the number that has no x attached to it. All I need to do is just plug these numbers in. So I have negative 3 plus minus radical 9 minus 4 times 1 times 11, or 4ac, divided by 2, right? Because 2 times 1 is 2. Now let's evaluate whatever's in the parentheses. 4 times 1 is 4, and 4 times 11 is 44. Now I'm left with 9 minus 44, which is going to equal to negative 33. Now, negative 33, does that exist? Can I take the square root of a negative number? The answer is no, I can't take the square root of a negative number. So the roots are going to be imaginary. And this is where this a plus bi comes into play. This a plus bi is a way to express imaginary numbers, right? So in this case, it would be mathematically incorrect to write a negative inside of a radical sign. So people developed this new way to express that notation using imaginary numbers, right? Their imaginary number is equal to the square root of negative 1. Now you may be saying, well, hey, isn't that like not legal math-wise? Can you not take a square root of a negative number? And you'd be right. That's why this is an imaginary number. This is not real, it's imaginary, right? You have to imagine that this is allowed in order for this 0 or this solution to be true. Okay? So whenever you want to write something in a plus bi form, you're going to have a regular real number here with no I, and you're going to have a imaginary number with the I attached to it, okay? So how do I get an I out of radical negative 33? Well, that's simple. You get rid of the negative and you slap an I at the end of the radical. You don't put the I inside of the radical. You can either put it on the outside over here or at the end over here, okay? Just don't put it inside of the radical. Mark off that the end of the radical is over here, okay? So now you have negative 3 plus minus I radical 33 over 2. Now, how did I do that? Well, you need to remember that a rule about multiplying radicals. If I have radical a times radical b, that's going to equal to radical ab. Okay? So, radical 33 times I, which is just radical negative 1, is going to give you radical negative 33, which is what I started with to begin with. Now, is this my answer? Also no, because I need to have a plus bi. So far, this is all one number. I need to split this up into a real number and an imaginary number. Luckily, whenever you're dividing by the same number, you can just split the fraction in the middle. So you can change this into negative 3 over 2 plus minus I radical 33 over 2. Or negative 3 over 2 plus I radical 33 over 2. And negative 3 over 2 minus I radical 33 over 2. That's all you needed to do for this problem. Okay, so that's going to be all of part 2 gone over in one video. If you want to continue watching this and continue the review of this video, part 3 is already up and in the description of the video below. If any part of this test confused you and you want to ask any questions, feel free to leave them in the comment below. I will try to get back to you as quickly as possible. If you want me to go over any specific tests, also leave those recommendations in the comments. Other than that, I hope you learned something and I hope you have a nice day.